Okie dokie. Use Trig Pythag to solve problems involving bearings. So this is when we're on a 2D surface and we're trying to figure out which way we're going with things. So these have fancy names. These guys are called the cardinal directions, or specifically north, south, east and west are called the cardinal directions. The others are just combinations thereof. I would expect that you've definitely heard of north, south, east, west, and northeast, southeast, southwest and northwest. But you may or may not have heard of things like north by northeast, east by northeast, and so on, with the ones in between. Just like how northeast is halfway in between north and east, north-northeast is halfway in between north and northeast. If you want to say it properly, so north by northeast, north by northeast. But if you just say north-northeast, that's going to work because we're not going to be writing paragraphs. Cool. Other things that we have to tick off just before we go any further. So if I'm in this direction down here, that's south 10 east. So basically that means start at south, then go 10 degrees to the east. So that's fine, that's cardinal notation. Alternatively, you can use what's called a true bearing. So true bearings always start at north and then always go clockwise until you hit whatever direction you're in. So in our case here, that would be 170 degrees true, because we were 10 shy of the 180. Beautiful. Even if it's like 5 degrees this way, that's 355 degrees true. You always have to go all the way around clockwise. Just to let you know, you always start with either north or south in cardinal directions. So you could have north 80 east. You wouldn't have east 10 north. It's always north or south first. Beautiful. Okay, so we've got that cleared up. We're now going to do this guy. Jim leaves camp, walks 5 k's north 40 degrees east. He then walks another 8 k's, 300 degrees true. How far and in what direction is camp from Tim? Okay, well, there's a bunch of words and a bunch of numbers. As always, generally a good idea. Words suck, pictures good. So, we're going to draw some pictures. I'm going to start a little bit low because we know that he walks north and east. So there's that. I'm going to call that C for camp. Great. He travels north 40 degrees east. Okay, so we're going more or less northeast 40 degrees. It's a bit shy of a perfect diagonal. Okay, I'm going to call that there. Cool. Great. That was, how far was it? 5k. Beautiful. That was north 40 degrees east. So if I draw in a dotted line there as my north reference, this would be 40 degrees. Beautiful. Okay. He then walks 8 kilometres, 300 degrees true. Well, where's 300 degrees true? It's 360 all the way around, so I'm 60 short of all the way around. So it's going to be super rough. Oh, that was terrible. Hit the top of the board. Something like that. Okay. Cool. Now, is it immediately obvious? Oh, maybe it is. You should overshoot, but it may or may not be, so don't let that ruin your day if you end up with numbers where your drawing you might have stopped here instead of out here. That's fine. It doesn't matter that much. The math will work out either way. This is 8 kilometres. Okay. Now, for the trickier bit, I'd rather not have to draw in 300 degrees here, because that gets a bit fiddly. It's actually easier to think, well, hang on, this is just 60 degrees here, because if it's 300, if I add another 60, I'm back to the start. You can do 300 if you want, but you're just going to be wasting a bit of time and making your diagrams really messy. Beautiful. We now want how far and in what direction is camp from Jim. Okay, well, that's going to be along, we'll go green for this, because that's my goal. I want that distance. And then I also want in what direction is camp from Jim. So that means think of yourself as Jim, which way is camp? Okay, well, that's going to be all of that angle there. So from north all the way around. Cool, so we should get a southeast sort of direction, something between 90 and 180. But we'll worry about that last. Now, if you've already done sine or cos rule, you can knock this out mildly quick. Oh, actually, can you? No, you can't. You still have to do it the long way. Okay. So I've got this triangle, but there's no right angles in that triangle. Well, what I could do instead is go, well, hang on. If if I draw in my own right angle triangle here, okay, I know that bit's 40 to straight up, so this bit must be, what, 50, because that should add up to 90. Great, okay, well, that tells me that this bit is 40. Cool. And then if we want, we could say, oh, that's 40, that's 60, this must be 80. Okay, great. Now if you know your sine rule and cos rule, you could get that green line straight away. So you're welcome to do that on the side if you so see fit. Otherwise, we're going to continue going along. So what I need to know ultimately is this green line. Well, I can make that up by doing a triangle down here. Cool, alright, I'll call this my x direction, I'll call this my y direction, because it helps if I keep things in the normal setting, x that way, y that way. You could call this E and N if you wanted, or sorry, south rather, S and E, since we're going in a southeasterly direction, but I'm just going to call them x and y, that way I don't care about if I've got southeast, north, west correct at the start. Beautiful. Okay, that's that. And we've also got another triangle I can draw in up top. Beautiful. Okie dokie. Well, how can we get some stuff going on? Well, let's see. I've got a whole bunch of bits and pieces. I'm going to call this, I'm going to avoid A, B, C, A, O, and H. So what else have we got? We'll go D and E. And we'll go F and G. Cool, just so we don't confuse ourselves with the notations. Okie dokie. Well, I want to get these two. Well, if we notice, y is just going to be E plus F. And x is going to be G minus a D. Beautiful. Once I've got those two, I can use Pythag to get that diagonal. Okie dokie. Well, that's all well and good. So, so I'm going to need to get these E's, D's, F's and G's. Well, that's okay, because I've got this red triangle here, which we'll redraw down here. This is E, this is, sorry, that's D rather, not F. Right angle, this was 50. The other one's 40, I'll just keep the 50 for now. Great, so we've got that. And so this is 5 kilometres. Okay, can we get D and E? Well, yeah, we've got one side and one angle, so we should be able to use trig for this. Okay, I'm going to go sine first. Sine of 50 equals opposite, E over hypotenuse, 5. Cool, a little bit of rearranging. Sine of 50, which roughly equals some terrible number, which I need my calculator for. Okay, my in degrees, yes. 5 times sine 50. Gives me 3.8 garbage. Cool, I'm going to keep that answer in there because I prefer exact. Okay, great. We also want D. Alright, well D is adjacent hypotenuse, so that's cos. Cos of 50 equals adjacent over hypotenuse. So D equals 5 times cos 50, roughly equals 5 times cos 50, 5 times cos 50, yep, bang. 3.2 garbage. 1. Beautiful, so I've got 2 lengths down. Great, now I've got E and F, I still want F and G. Alright, and my hands are getting too full with texters, to the point where I'm dropping things. Alright, next thing, draw it out separate, keep your working name. Beautiful, this is 8 kilometres. All these distances are in kilometres, I'm not going to bother to keep writing them because it's just extra letters in my working. Okay, great. Well, we had, this was 60. Cool. Great, can we solve this? I've got an angle and a side, so yeah, I should be able to use trig to find anything else. Okay, I'm going to find F first. So that's adjacent and hypotenuse. Adjacent hypotenuse is cos. Cos 60 equals adjacent over hypotenuse. So we get 8 times cos 60 equals f, which roughly equals something. Oh, why did I write it that way around? Could have written it, doesn't matter. 8 times cos 60 is bang on 4. Well, that's convenient. It's not even roughly, it's exactly. How beautiful. Cool, we still need g, so that's going to be sine 60 equals opposite g over adjacent 8. Oh, of course, because it's 60. Good job. Cool, so I've got 8 times sine 60 equals g, which roughly equals 8 times sine 60, 4 root 3, 6.928. Garbage, garbage, garbage. Beautiful. Now you could have the third exact answer in there if you wanted, so that equals exactly 4 root 3. But I'm going to leave that. It doesn't matter which one you do for now. Beautiful. Okay, so I've got all 4 of my E, F, D and G's, so we can start doing a bit of work. So E was wherever it was there, F was wherever it was up here. So we're going to end up with roughly 7.83 garbage. G minus D, what was G? G minus D gives us what? 3.71-ish. And something like that. It'll round to 372, but depending on where we want to round, we can do that later. Cool. Actually I'll type those in now before I forget. So this guy, and 4 is one of them, 7.83, yep. And then 69 minus the 32. Go 1, 4. Oh, it doesn't round. There you go. If you use exactly the 714, so that works out okay. Cool. Alright, so we've got x and y. Great. We still want this diagonal, which unimaginatively I'm going to call z. Okay, well we know x squared plus y squared equals z squared for this, because it's Pythag. Great, okay, sub these guys in, so this thing squared plus the other one squared. Cool, and then square root that. .666, that's ominous. Cool, so we've got our distance away from camp. Fantastic. Units, since this is an actual answer. Kilometres. Great, well we still need to figure out which way he needs to go. So we've told him, great, you're 8.666 kilometres away. And then he says, thanks, fantastic. Which way though? Alright, so we need to figure out this angle here. Alright, well, we've got a couple of ways of doing that. But what I would suggest is, if we take, we'll draw it on this one first actually. I've got, this angle is 60, that's 90, therefore this one up here has to be 30. Okay, fine. Oh, actually I don't even need that. Never mind, I don't even need that. Forget that. Cool. I've got this green triangle. I'm going to put a north-south up there. The angle I ultimately want is that one there. Well, this guy plus this guy would be 180. So we'll call this theta, unimaginatively. In fact, yeah, no, we'll call it theta, it's fine. Yeah, that's fine. Okay, well, we know now that this side was y, which was whatever it was, 7.8-ish. And this side was x, which was 7.1-ish. Cool. Can we find that angle? Well, yeah, I've got two sides, so I should be able to find angles. O and A, so tan theta equals O, 3.7-ish, over A, 7.83-ish. Cool. Theta, approximately, equals, I need to inverse the tan for this, of these crap numbers. And we get some terrible number. Tan inverse, open bracket, First thing was the 3.7 number. Divide by the 7.8 number. Put the bracket. Roughly equals 25.37 something degrees. Fantastic. Okay, are we done? Well, no. This was that green angle. We want this black angle up here. All right, well, the black angle, that's 180 minus this guy. So 180 minus my last angle, which we'll have to give a name. We'll just call that, I don't know, alpha. I'll know. Alpha equals 180 minus theta. Pens everywhere, which is that one. So that's roughly equal 154.62-ish. Cool, okay, great. So that's that. We should combine it all together to get an actual answer. It's actually meaningful. So how far? Well, that's nice and easy. 8.66-ish kilometres. Depending on where you round, you'll get slightly different things. And then we need to give a direction. You could give it one of two ways. You could say, oh, it's a 154.62 degrees true. Or you could have said 8.6 kilometres and we're in the southeast. So southeast, how many degrees southeast? We always measure from top or bottom. So we're measuring from south out that way. So that's going to be the 25, need to make more space, 25.377 degrees east. Either of those are totally fine. The book might flip-flop between them, so you have to be able to jump between them as well. And that's it. So that's 4D. Most of this is just going to be take the words, turn it into a pretty picture. The math itself isn't overly complicated. So long as you draw a pretty picture, label the bits and pieces, set out a game plan, and then just carry out the game plan. I highly recommend as well that you draw sub-triangles. So rather than having a really busy diagram, have a few neat diagrams because it's easy to think when the drawing is neat. Beautiful. Other than that, if you've got any questions, email me. Cheerio.